Hello everyone, welcome back. This is Engineer Hussein Masabi. So in this video, we are continuing vector addition in 2D using the parallelogram law. Now in the first objective, we did look at how to determine the magnitude of the resultant given two vectors. Now in this case, our next objective, which is objective 1.5, will be to find, or learning how to find, say, the magnitude of the components given the resultant. Now, how do we find the magnitude of the components given the resultant vector? So the procedure is similar, not even say similar, it's one and the same as with the procedure we applied in objective 1. So let's understand this with an example. But before we get to it, don't forget to like and subscribe. Alright, so the question says, resolve the horizontal 600-pound force in the figure into components acting along the U and V axis. So which means that the components of the resultant force, which is 600 pounds, is acting in the U and the V. Alright, don't get confused with LB. LB is just simply some other unit for weight, and weight is the type of force, which simply means that we're playing with force vectors. Alright, so after that, we've been told to determine the magnitude of these components. Alright, so let's begin. So let's follow the same steps. So step 1, remember, if you can recall, step 1, we have to extend the lines. Alright, I don't think I'll be writing the steps. I just hope you watched the first objective. If you didn't, you can always go back to the playlist and check out the video on how to find the magnitude of the resultant given two forces. So step 1, let us extend the lines. So we're going to extend the lines of our components. So we're having U and V. So I extend U, also extend it this side, also extend V. Now after that, we're supposed to draw parallel lines. So I'm going to draw a parallel line of this guy here, U, which will be parallel, or that which will pass through U, because this is V and this is U. So I'm going to draw a parallel line of U that will pass through V. So it can be there, it can be anywhere. We can also extend the resultant line. So when I draw the parallel line of V, it can be here, it can be there, it can be at any convenient point, provided that it will give you a clear image of what you want to find. So I will draw it somewhere here. So this line is parallel to that line. Okay, I don't think my drawing is nice, but you know, you guys can draw better lines than I do, so just make sure you draw something that is looking nice. Okay, so if you recall from the steps, once you draw the parallel line here, the next thing to do is to draw a parallel line of U. So we're going to draw a parallel line for U, but make sure, since the parallel line of V is touching the result, because here we already have the line for the resultant, so let's be careful. So the line for the resultant is in this direction, so the parallel line for V has touched the resultant at that point. So even the parallel line of U should touch the resultant at this point. Remember, the P point. So the parallel line of U, I can't start drawing the parallel line of U there. It won't give me a clear value and it will be difficult to compute. So I have to draw a line that will pass through this point like that. So I'll draw it neatly like that so that I can obtain my quadrilateral. I have that point, the point of interest, this point, and that point. After that, I can draw the quadrilateral at a separate point. So I'll draw it, let's draw it this side. Okay, so once we do that, remember we need to find the angle in between the two vectors. So we're having this one here and that one there. So we need to find the angle in between this angle there, according to the steps. Now, if you look closely here, you will find that finding this angle is going to be a bit tedious, but rather I can use some principles or some rules that are applied under angles. So I want to find that angle that's in between, but since I can't find it, let's find all the possible angles. So from the looks of things, you'd find that since according to angles we have different principles. We have the Z principle. We have so many assumptions. When I say assumptions, so many rules that we have to follow. So let's just use the Z principle. In most cases, we'll just be using the Z principle. So if you look at what you have, since this line is parallel to this line here, I'm having this angle here. So if I draw a Z here, a Z like that Z, you'd find that this angle is equivalent to this angle according to the Z principle. So it means that whatever I have here, which is 30, will be equivalent to what I will have here, which is what? 30 degrees. Now that I have this 30 degrees, I know that even this part here will be what? 30 degrees, because it's a quadrilateral. Because if this is 30, automatically this one becomes what? 30. So you should always use all possible means to find the angles. So after that, we can find the angle in between the two vectors. So I'll say x plus 30 plus 30 is equal to 360. So this is 2x plus 60 is equal to 360. So 2x is equal to 360 minus 60. So 2x is equal to 300 divided by 2, x is equal to 150 degrees. So now we know that the angle here is 150. So this is 150, and this 150. Now that we know that, we need to bear in mind of something very important. We were given the resultant line, and the resultant line is not coming from the 30, rather it's coming from this point, because this point is the center in our case. This is the center. So that's our center. So which means that the resultant line is coming from that point, touching this point, which means this is our point of what? Interest, the P point. So with this in mind, all we have to do is now write that FR there. Now since this is FR, we need to understand something. So I erase this. That's gone. We're having two shapes, shape A and shape what? B. So according to the rules, we have to pick one shape. So I will simply pick shape A. So I'm having 30 degrees there, and I'm also having this resultant line here. The resultant line is simply equivalent to 600 pounds. So I write my 600 pounds like that. And then this line here, remember, this V is parallel to that V. So this is also what? V. Because this was our V, it's parallel to that V. This was our U. So this U is parallel to that U. So having V, and then this is simply U. Now we only have 30 and the 600. We need to find something that will give us more information. Now, what are we supposed to do next? Now, if you look clearly at the image that you have, there is another angle we can find. If you look here, this is being directed at that point. We're having that. So this means that even this angle here we are given forms a Z principle with that angle. So if you find that the procedure of where you find the angle in between is not working, just apply Z principles to find the missing angles. So this angle is equivalent to the angle you have there. You see? So from our quadrilateral that we drew, that angle is there. That's the 30. And that 30 is equivalent to the 30 you have there. So the 30 I'm having here will help me with everything. So that 30 is here. Like that. So I can find the other angle here, which is theta. This is a triangle, it adds up to 180 degrees. So what we do is to say theta plus 30 plus 30 is equal to 180. So theta plus 60 is equal to 180. So theta is equal to 180 minus 60. So theta is equal to 120 degrees. This means that this angle is 120 degrees. Now that we have that, we can simply just draw this triangle at the point where we'll see it clearly. So I'll draw it here, draw it a bit bigger. So we have 120, we have 30, we also have 30 there. I'm having the 600 there. We have U and V. So now we can find the components using the sign rule. So remember, start with what you have. So I'll say sine 30 over 600 is equal to what I want. I can start by looking for U or V. I'll start with U. So that portion. So I'll say sine 120 over U. Then I'll cross multiply. This will be sine 30 times U is equal to 600 times sine 120 divided by sine 30 divided by sine 30. U is equal to, if you compute this, you will get 10 point, sorry, not 10. Let me just get my rubber. Reduce the capacity like that. Okay, so what we get is 1039.230485. If I round off to two decimal places, then U is equal to 1039.23. The units of the resultant was in pounds, so even the component would be in pounds, like that. So we have found that of U. So we can find for V. So I just erase this part like that. We start with what we have. So let's going to be, write it here, sine 30 over 600 is equal to what I'm looking for. That's V. So this guy here, which will be sine 30 over V. Cross multiply, we have V times sine 30 is equal to 600 times sine 30. Since I'm looking for V, I divide by sine 30, even this side, I divide by sine 30. So V will be equal to, if we compute this, we get 600, which means the final answer is 600 pounds, like that. Alright, so remember how to go about doing this. We're trying to simply just find the magnitude of the components given the resultant. Now remember the steps that we had to follow. We had to extend the lines of the components as well as the resultant. After that, we had to draw the quadrilateral to see if we can find any possible angles that can help us determine what we want, because the whole goal is to have a triangle that will either use the sine rule or the cosine rule to find what we need. So we tried to extend the lines. As you can remember, we extended all the lines, did the extensions, we came up with some shape, came up with the quadrilateral that was this nature, yeah, something like that. So we had to have that. So we determined the angle in between. Since the resultant was coming at that point, that's the reason why this one had to be cancelled out, because wherever the resultant is coming out from, we always neglect the angle that is there. But we considered the angle that is here from the Z principle because of the parallel lines. So this was also 30, giving us a 30 there. Because of the aspect that this portion here is 30, if we apply the Z principle, this is also what? 30. So we ended up finding the angles that we needed there. Same thing with the angle that we needed there, which is 120, equivalent to the 120 there. And we had to apply the sine rule by picking one of the shapes. So that's literally the procedure. Follow the same procedure following in objective 1. Yeah, and you will find the answer that you want. I know at first glance this might look a bit of messy and difficult, but with practice, just going through these objective examples I'm giving you, you'll be able to solve a lot of fundamental problems and a lot of problems that might be brought where you will need to find the magnitude of the components given the magnitude of the resultant. Alright, thanks for watching. If you have questions concerning this, you can always reach me on WhatsApp on 077 149 5252. Remember, slower progress is better than no progress. And don't forget to strategize before you become a statistic, and let's try and push for that A+.